Welcome to the presentation of the ceasefire demo for use case 3, Firearms purchase on dark web marketplaces. It is a demonstration of advanced capabilities in natural language understanding, visual analytics and correlation graph creation. Following a brief introduction, we will proceed to analyze the utilization of the tool. The ceasefire tool focuses on dark web marketplaces with three primary objectives: developing technologies for systematic crawling of the dark web to gather vital data on illegal firearm markets, assessing solutions for extracting, presenting, and interactively exploring this information, and developing functionality to recognize online entities and detect similarities between marketplaces. Additionally, the tool offers a cryptocurrency transactions analysis to identify patterns and correlate information on extracted entities, potentially revealing their true identities. The ceasefire tool user, after logging into the application, initiates a crawl using dark web marketplaces links. The crawling process culminates in the creation of a number of alerts, each one corresponding to a specific marketplace listing. By automating this process and generating alerts, the tool spares LEA users the need to access the dark web directly. An example of a dark web marketplace can be seen on the screen, along with a number of firearm and drug-related listings. Examples of the generated corresponding to firearm listings alerts, as well as the way the user can interact with them, will be presented shortly. Starting off, the user has the options to choose between two distinct filters, each leading to a different presentation of the extracted listings. The simplest choice of the existing filters involves grouping listings by marketplaces, which displays a list of all crawled marketplaces. Clicking on a marketplace reveals all related listings extracted from it, as you can see on the screen. Secondly, the user can choose to fill in a date range. All marketplace listings created in this range are consequently presented, grouped by marketplaces as well. Continuing on, the content summary of each listing can be seen when the listing title is clicked. For example, this listing presents a Black Aces tactical shotgun with a price of $415. Other info includes the classification of any images found in the listing, as well as any extracted cryptocurrency addresses. If the LEA user deems the listing noteworthy, they can click the Show Details button. This button opens a wider window containing all information that has been extracted. As you can see here, the general listing information is shown. This means the marketplace name it has been extracted from, its onion link, as well as the listing name. Further information is provided in this drop-down menu, such as the product name, its price, and any extracted specification. Its description is also shown, allowing the user to read it with a click on Show More. Finally, the product category as well as the number of items in stock can be seen. Regarding the visual analytics part of the tool, the classification of any extracted images is shown here, as well as the classification model's confidence level. For example, here, the image that has been found has been classified as a shotgun with a confidence level of 91.5%. As you can see, the user can also see the extracted images with a click of a button for further scrutiny. Moving on, the cryptocurrency analytics part of the tool, a plethora of information is also presented. More specifically, the information pertinent to the detected address is displayed in the description text. The report highlights the type of cryptocurrency address which corresponds to the blockchain platform it belongs to. Currently, this includes Bitcoin and Ethereum addresses. Moreover, the detected address is considered the seller address, as there is no way for a user address to appear in a listing page. The listing name in which the address was found is specified. Additionally, the report notes that suspicious transactions with amounts matching the listing price were detected by the cryptocurrency analytics tool. Below, the user can see the correlated cryptocurrency addresses, which for now show addresses with suspicious activity, meaning participation in suspicious transactions with the seller. Moving on, potentially suspicious transactions are displayed. These transactions are detected by searching the blockchain transaction history of the seller address with values that match the listing price. The report indicates the seller and buyer addresses, suggesting potential involvement in the illicit exchange. Further details include the date and time of the transaction. Overall, the user is presented with a comprehensive overview of concerning activities related to the sale of a firearm on the black market, including associated cryptocurrency transactions and involved parties. Finally, the user is granted access to any correlations found between this listing and other similarly sourced information, whether online or physical, in the form of a graph. When the Generate Graph button is clicked, a graph containing all correlated information with this listing is presented. For example, here we can see the connection between this listing, which is the green node, and the cryptocurrency transaction based on the price of the firearm. This is the cryptocurrency transaction. Furthermore, a connection with a scanned parcel image can be made due to the date and firearm category. More information about the creation and use of correlation graphs are presented in the final demo. With this listing, we end the demo presentation for use case 3, firearms purchase on dark web marketplaces.